Alright, this is Advanced Concepts, Week 7. We're going to focus on cholesterol formation and then how lovastatin will affect inhibiting high cholesterol formation. Now, cholesterol, a lipid being hydrophobic, it's required for many reasons. So, first off would be vitamin D synthesis, steroid formation, use in membrane structure, and it's also used to form bile salts. Too much cholesterol can build up in arteries, causing them to harden and then restrict blood flow. And then this can cause a cutoff of oxygen supply, which can then lead to heart attack and strokes. The synthesis of cholesterol is in 3 main stages. So stage 1, the synthesis of isopentenyl pyrophosphate. And then stage 2, going to be the formation of squalene. And stage 3 is going to be converting to cholesterol at the very end. And then later in this presentation, we're going to focus on lovastatin and how it will target a specific part in order to inhibit the formation of high cholesterol. So stage 1 is going to be the synthesis of isopentenyl pyrophosphate. The formation of 3-hydroxyl 3-methylbutyryl CoA, also known as HMG-CoA, is from acetyl-CoA. Then HMG-CoA reductase converts to mevalonate, and then stage 1 continued. Mevalonate is then converted to 3-isopentenyl pyrophosphate. So mevalonate goes through a series of steps being phosphorylated. So one ATP is going to add a phosphate group here, another ATP is going to do the same, and then a third one, and then at the very end we're going to lose a phosphate and CO2 in order to form 3-isopentenyl pyrophosphate. Stage 2 is the formation of squalene. So squalene is made up of 30-carbon chain, which is synthesized from 6 molecules of isopentenyl pyrophosphate, which is a 5-carbon chain. So if we look at diethyl pyrophosphate, we're going to add isopentenyl pyrophosphate. So a 5-carbon plus 5 carbon is going to be 10-carbon geranyl pyrophosphate. Then we're going to add another C5 isopentenyl pyrophosphate, which is going to form C15 farnesyl pyrophosphate. Now we can add 2 farnesyl pyrophosphates together. So C15 plus C15 is going to give you C30, which is going to be squalene. And then stage 3 is the conversion into cholesterol. So squalene will cyclize to form a ring-like structure. So you see here, it's going to start forming into more of a ring-like structure. And an ADPH plus a hydrogen and oxygen is going to give us squalene epoxide. We're going to add a hydrogen, which is going to form protosterol cation. We take out a hydrogen, which is going to form linosterol, and then we go through 19 steps. HCOH plus 2CO2 leaving is going to give us cholesterol, our end product. Now, lovastatin is an inactive lactone, which is hydrolyzed to corresponding beta-hydroxy acid formed in the stomach. It's an HMG-CoA reductase inhibitor. So lovastatin, being an HMG-CoA enzyme inhibitor, it will inhibit fatty acid synthesis and is responsible for lowering cholesterol. And it does this by targeting HMG-CoA's reductase. So at the very beginning, at step 1, stage 1, we have the 3-hydroxy 3-methylbutyryl CoA converting into mevalonate. But if we inhibit HMG-CoA reductase, we pretty much stop the cascade, which will form cholesterol. So we reduce cholesterol in the very end. And so lovastatin is structurally similar to HMG, a substitute of the endogenous substrate of HMG-CoA reductase. Lovastatin is a prodrug that is activated of the lactone ring to form the beta-hydroxy acid. The hydrolyzed lactone ring mimics the tetrahedral intermediate produced by the reductase, allowing the agent to bind to HMG-CoA reductase with 20,000 times greater affinity than its natural substrate. So the bicyclic portion of lovastatin binds to the CoA enzyme, a portion of the active site, and that's how it inhibits it. So these are my sources. I mainly pulled a lot of the information from the book itself, but I also used some of the websites in order to get some imaging and additional information. So that's my presentation on cholesterol and how lovastatin inhibits formation of cholesterol. If you have any questions, give me a comment or give some feedback. Thanks. Take care.